what is that? Rad 2 to 2? Is that right? Is that right? You can look at the paper, Jeff. There we go. Thank you. You guys see why this is not a U sub problem? I would have some people that would say, well, the derivative of that is in there, Jeff, but not really. It's 1 over x, so it's not really in there. This is a radical, it looks like a squared and a constant. That automatically means trig sub. If I don't see something else, like if it's not U sub, this form is just screaming for trig sub. Okay, so can somebody tell me what's wrong with this? There's a number there that I can't have there to do this. 2, right? So I got to factor that 2 out, right? I know you guys are going to just love me for this, but oh well. This kind of goes along with the, we're not going to get like 4 all the time. So if I factor a 2 out, I actually have to factor a rad 2 out. Is that cool? Let's factor a rad 2 out. So then I'll have x squared minus 2 over x. Is that cool? Now let's see who remembers. Of course, you can look at this paper too. Which trig sub?
Tangent secant squared minus 1.
Yeah, so you're going to want to let x equal, now we got to be careful now. If it was x squared minus 9, I would let x equal 3 secant, right? X squared minus 2, so I got to let x equal, do it. So again, let's do this. If I saw x squared minus 9, I would let x equal 3 secant theta.
So it's root 2, but...
Yeah. So here I've got to let x equal to square root of 2.
Root 2
Secant theta.
Yeah.
Not what you would prefer, but not that bad. It's just a freaking rad 2 sitting there. It's not doing anything to us. Right? Now again, I want you to see, why do we do that? Because what is x squared then? What's the square root of 2 squared? 2 secant squared. And see, if I put a 2 secant squared there, I could take a 2 out. Yeah. Secant squared minus 1 is? Tangent squared. Yeah. So just the same way you should be able to tell me what the cosine of 30 degrees is pretty quickly, you also need to be able to bring up these identities pretty quickly. Okay. The more you know those identities, the less this is a guessing game. I really want you to understand that, because it wasn't made clear to me as a student. Trig sub is built directly on Pythagorean identities. The form of the problem tells you which thing to use. It's crazy. Okay. So what's dx? The rad 2 just comes from the rad, right? Derivative of secant? Secant tangent. Poor little guy. Okay. With my writing, you don't try to read it. You just try to feel it in. Okay. Sorry. You're chosen for it. All right. So let's see what the hell happens here. Let's just start throwing shit in here. Let's see. I'm going to do this. Well, will I? Yeah. All right. There's 2 different ways we could do this. And to be honest, it's much better to change the limits. Because I don't then have to go back to theta. I don't have to set up triangles, all that kind of shit. Okay, quickly. So remember, when you make a substitution, don't you need to change the limits? So it's really, to be honest, I think it'd be about the same amount of work either way, but what do you guys want to do? You could either keep the limits and at the end go back to x, or we can change the limits right now. Change the limits? Yeah. Okay, so what that means is, when x is rad 2, what is secant? So then you have to solve this equation. Right? It's a bit of a trade-off. Do you see that? Right? When x is rad, because this is x. This is what x is doing. So when x is rad 2, I got to figure out what theta is. Because now I want to make this d theta, don't I? So when is secant theta 1? What is secant? 1 over cosine. So when is cosine 1?
0.
0. I love it. So theta equals 0. And when x is 2, what is theta? 2 over rad 2 is rad 2. Is that cool? A whole 2 divided by half of 2 is half of 2. And then if you just bring it back to cosine, you got rad 2 over 2. When is cosine rad 2 over 2? 5 over 4. Kick ass. Again, you didn't have to do that. You could have, it's a trade-off. Either you do those equations, figure it out, or at the end you have to bring x back. If you leave these are what x do. You can't plug these in for theta. Okay, maybe. So now let's see what we get inside. Let's see. Dx is this business here. X is square root of 2 secant theta, right? And square root of x squared minus 2, it'll be 2 secant squared, let me just do it. All right, it'll be 2 secant squared minus 2. Oh, I just don't want to write so much. At least if you guys can handle this. All right, let me stop for a minute. All I did there was just throw shit in, right? Just pure substitution. It's very mindless. Dx is this. X squared is this, right? So it's just nothing major. Now I got to come in and go, oh man, what can I do? So up top, you see how I can pull out another rad 2? Maybe? So I can pull, so let me see. This is going to become rad 2 times the square root. Now what is secant squared minus 1? Tangent. The square root, well, tangent squared. And then square root of tangent squared is tangent. Okay. Crazy. So, look what happens. This square root and this square root cancel, right? Let me stop for a minute. Okay. This square root of 2 times this square root of 2 makes a whole 2. Aw. And then I get tangent theta times tangent theta is tangent squared, and secant theta cancel. All right. That looks a lot better. Unless you guys are like, what's the integral of tangent squared? Which is a really good question. I don't know what that, I know how to rewrite that though. Let me stop for a minute. I really want you guys with me. All I did, is everybody cool with what we picked here? That got everything rolling, right? I need dx. Okay, if I know x, I know dx. X squared, you don't have to do this, but I just put it there. That goes there. Dx is that. X is that, right? It's just substitution. And then many times you'll have stuff cancel. That's awesome. Yes?
So I see where your secants canceled out. I see where your square root of 2 canceled out. But what did you do with the 2 outside the integral to make it the integral of 2?
Well, here's half of 2, right? So if I take it out, there's another half of 2 that makes a whole 2.
Okay.
Yeah. Okay. I like it. Some of you guys look like you want to hurt me. I really, really hope. The hardest step so far was this. Everything else was just simple derivative, substitution, and then simplification. I haven't really done much yet. Yes?
It might just be my eyes, but like right in purple, right above the square root.
Yes.
What does that say?
Yeah, no, it's not just your eyes. It's my horrible writing combined with me writing very tiny. So I took a rad 2 out. Is that cool?
Yeah.
Secant squared minus 1 is tangent squared. Square root of tangent squared is tangent.
Okay.
I just didn't want to rewrite the whole damn thing. Now, tangent squared theta. Not easy to integrate directly, but can I use an identity?
Sure.
What do you wish was in there squared? What's easy to integrate squared? Secant. What is tangent squared theta?
Secant squared plus
shit.
1.
It's not shit. Where's C shit? All right. So yeah, tangent squared is
Secant squared plus 1. Oh,
Yeah.
minus 1.
right. And the integral of secant squared is easy. Integral of 1's easy. Yes? You pull this up here. I don't even know if Scheisse, Jeff. Oh, good. You got all that. Okay. All right, I'm going to come. Let's see. What can I get rid of? Get rid of all this. And you. And you. Oh. So we bring this over here. Integral of secant squared is tangent. Integral of 1 is theta from 0 to pi over 4. What is the tangent of pi over 4? 1? Like a pi over 4 in? What's the tangent of 0?
0.
0. And plug a 0 in. So you get 2 minus pi over 2. Neato. Yeah, okay. Nice. No, I really, again, you have to let me know the minute I kind of lose you. You have to let me know the minute that happens, because it's really hard to backtrack. This got everything started, and how do you tell which trig function? It's the form this is in, right? If I saw number minus x squared, I think sine, because 1 minus sine squared is cosine squared, right? That's how that relates. Yeah.
Can you repeat the first 2 steps, please?
First 2 steps. So the very first step was to take a rad 2 out. I need a 1 here for this to work. Then I realized that secant squared minus 1 is tangent squared, so I know I want a secant there. But I need it to have a coefficient of 2, so I can take that 2 out. So it actually has to be rad 2. So that when I square it, I have 2. So what number goes in front of the trig function you pick? The square root of that number. So that it ends up agreeing with itself, right? Okay, the more you understand why things happen, the less it's memorization. The more it's just, I do it because it makes sense. Yes?
Can we see it the other way of converting back to x's before
Oh,
we
sure.
evaluate?
Yeah. All right. So, before I do that, any other questions on what happened up here? All right, so Gerald's got a really good question. He's like, okay, Jeff, what if you had decided to keep this and then go back to x, right? Okay, because on indefinite integrals, you're going to have to do that. So let's see. So let me back up to, well, actually, so all I'm going to do is I'm going to keep this as 2 and rad 2. And what I always used to do is I put it in parentheses to remind me that that's not what theta does. That was just my own notation that I created. Oh shit, of course I just did that. So if you have to bring it back to x, you need to know what, oh shit, Jeff. You gotta go one more step. So this will be 2 tangent theta minus theta. Okay, from rad 2 to 2. Now I'm gonna bring it back to x. So I need to know what tangent theta is. I know what secant theta is, right? And there's actually 2 ways to do this, but I prefer the triangle. Secant is 1 over cosine, so this will be the hypotenuse and this will be the rad 2. Is that cool? Secant is hypotenuse over x. And I want to know what tangent is, so I have to know what this is, which would be the square root of x squared minus 2. And again, you see that happen all the time. It kind of comes back. Okay, I love it. You guys are sort of paying attention. You're like, he finished that problem. And then here you just get square root of x squared minus 2 over square root of 2. That looks great. So that would go there. And then theta is going to be this freaky ass inverse secant of x divided by the square root of 2. Right? Just divide by square root of 2, take the inverse secant, that's what theta is. And then you have to plug in rad 2 and rad 2 into that. Right? Is that all right? It actually turns out to be the exact same math. You're just kind of doing one first and one second, vice versa. Okay. All right. So that one I wanted to do with you because it gets messy, but it isn't bad. I mean, my God, you feel great when you see this. It's much better than secant to the fifth theta, tangent cube theta. You're like, oh my God, which thing do I do? Okay. So I want you guys to try out part A. Part A, look at part A. Come on. Look at part A. So that's good. Bam. I will tell you this, it does become a problem from section 7.2, is that right? Yes, 7.2. We have to use an identity. So what are you guys letting x equal to get this thing started? Let me catch up to you.
2 sin x.
Beta. Yeah.
Theta.
I'm glad you said that though, because that'll really confuse the hell out of you. You don't want to make x a function of itself. I guess okay. So dx is 2 cosine theta d theta. So then you get the integral square root 4 minus cosine squared. Dx is 2 cosine theta d theta. All right, what do you do next?
That equals cosine squared.
Yeah, well, you can take out a what?
4.
Square root of 4.
Square root.
And then that 2, so I get 4. Is that cool?
Yeah.
1 minus sine squared, so that's cosine squared. Square root is cosine times another cosine is cosine squared. Now, you must bring your training in. So, cosine squared, it's the only thing in there. an even power. What do you have to use? I feel like I left. No. Oh. What do you have to use for this?
Power reduction?
Power reduction, right? The identity. I'll get it started. Something over 2.
1 plus cosine 2 theta.
Yes. Right? It's not that bad of an identity, and it immediately takes it from a squared to a first power. Right? This will only really suck if it was a 4th power, because then you have to square that. It's gross. Yes.
I'm sorry, how did the 4 get outside?
So here we took a square root of 4 out.
Yeah.
So we're left with that. Square root of 4 is 2. Times 2 is 4. Pull it out.
Okay.
Yep. So here I can just make this 2. Is that cool? Shaman. What's the interval of 1?
D theta. Oh, it's
Theta?
Sorry.
And the interval of cosine 2 theta?
Sine
Over 2. Good. You're going to kill that 2 that wants to come out. Now, why is it not good to just circle that?
because you have to switch it back.
Yeah, because the question was about x's, so it's like me saying, so what's Charlie doing? Well, Betty's gonna go. No, what's Charlie doing? What the shit? Don't tell me what this other thing's doing. So you can immediately get what theta is. Does anyone see that? If you solve for theta, divide by 2, take the inverse sine. That's gross. Yes? But we don't care, because I just throw it in. That's what it is. Let me clean this up a little bit. So this will be 2 theta. Of course, these 2's will cancel eventually. Now, what the hell do I do with this guy? Do we know anything about the angle 2 theta? We only know stuff about the angle theta, yes? So what do you do? In fact, if I wanted to, could anybody tell me what cosine theta is? Sine theta is x over 2. Is that cool? Could anyone tell me what cosine theta is? Could you get that?
2 over x.
Nope. That would be cosecant. Right. That's the reciprocal of sine. We've done this before. What do you draw?
Triangle.
Triangle. How do you figure out what goes where? Well, sine theta is x over 2. So this has got to be x, that's got to be 2.
The 4 plus x squared.
Minus, because that's hypotenuse. You see?
Oh.
So it happens a lot where you get that piece come back. That kind of only makes sense because that went into building this, so it's going to be part of what that is. So what's cosine theta?
Square root 4 minus x squared.
Now, right, you're all like, oh, you found cosine, who gives a shit? But sine 2 theta, how do I make that in terms of theta? I have to use a double angle formula, right? What's sine 2 theta? 2
sine cosine.
sine theta cosine theta. Right. By the way, real quick, just side note, what's sine 4 theta?
Square slash shape.
All we know is sine of twice an angle is 2 times sine of angle cosine angle. What is this twice of? 2 theta. So it would be 2 sine 2 theta cosine 2 theta. So be careful, it's not 4 sine theta cosine theta. You guys see that? So we're going to see that throughout the semester. There's a form. You have to know how to use the form correctly, right? That's not a 2 because that's a 2. That's a 2 because it's just a 2. This is theta because it's half of this. This is theta because it's half of this. So there's half of this, and there's a 2 that just sits there, right? Okay, that has nothing to do with this problem. So, like I said, just a side note. I announced it before I said it. So now I can do 2 sine theta cosine theta, right? So it'll be 2. What's sine theta?
X over two.
X over 2, what's cosine theta?
Yeah, that.
Square root of 4 minus the square over 2, and then you can kill it 2, and then it doesn't matter, plus C. Okay. So that whole process there, you have to get pretty comfortable with it. This is going to be the last step on a lot of these kind of problems. The minute you say this, you have identified a triangle. There it is, and then you can do all kinds of shit to it. You find out whatever you need from that triangle. Okay. Okay. Now, there's no questions on that one. Yes?
So the only reason you found cosine is just to use it in the double angle.
Yes, because I can't get sine 2 theta back to x because I have no information about the angle 2 theta. I only have information about the angle theta. Okay, so if it said cosine 2 theta, you would have had to use one of those identities to get it back to theta. Okay. Remember cosine 2 theta? Does somebody know what cosine 2 theta is?
Sine squared. Oh.
Cosine squared theta?
Yeah.
Minus sine squared theta, yeah. And then you can build the other 2 iterations off of that, right? Okay, maybe. Okay, so I want you to know you're not hung out to dry on these identities. You've got them up on Canvas. You can come by and see me in office hours. You can go get help, right? I'm not going to devote a large part of class time to teaching trig. I will do as much work as you need in office hours in the Math Study Center to get you up to speed. You with me? But it's crazy important to be up to speed on that. And I apologize if any past professor did not make a big enough deal out of that. Right? They didn't do their job pre-calculus. The whole job of pre-calculus is to get you ready for calculus. Okay, okay. So let's look at this last one. Has anybody looked at the last one yet? Well, look at it. Step number 1 in any problems. Look at it. Can you factor the bottom? Oh, 4x. That's better. Okay. Can you factor the bottom? No, not really. Not using whole numbers, right? Those are the only kind of numbers I really want, thank you. At the moment. Okay. Does this look like it's in some trig subform? Nope. But we're going to force it to be. Damn it. Let me do this. Okay. Ooh. Done so much. Did that? Does anyone see what I'm going to do? I said this last time. Complete the square. Do you remember completing the square? Love that so much. So here's the idea of completing a square. If I solve this, the question is, what do I add here so that it becomes something squared when I factor it, right? So what's half of 6 squared? So half of 6 is 3. 3 squared is 9. So I would add 9, and then it becomes x plus 3 squared. Right? And the reason that is, give me a number.
4.
4. Okay, good. What's x minus 4 squared?
What was the question?
What's x minus 4 squared?
X
Minus
squared.
Minus 8.
8x.
16.
Okay, how does this relate to this? That is
Half.
twice this.
Yeah.
That is this squared. So if I cut that in half, I will get this. If I cut that in half, I will get this. If I square this, I will get that. It's just noticing patterns, which is, 87.3% of math, just to make up a stat on the spot. Okay. So what's half of negative 4?
Negative 2.
Squared.
4.
If I add 4, I have changed the problem, correct? But you're not allowed to do. You're like, I don't like your problem. So at the same time, I better,
Subtract 4.
and now I've not done shit. I didn't do anything. maybe?
So what is it? It's you divide it by 2 and you square it.
Yeah, so the process is you take the middle coefficient, cut it in half, and then you square it.
Okay.
This is what it needs to be added. This is what this factor's like. The first thing you did? So x squared minus 4x plus 4 is x minus 2 squared. And what's this?
Plus 4.
There we go. Forgot my dx. All right, so you're all like, okay. How does that help, Jeff? Well, let me ask you, if the bottom was x squared plus 4, right, if this minus 2 wasn't there, first off, what trig function would we substitute? Tangent, because tangent squared plus 1 is secant squared, right? So we'd use some form. But so I would, if it was this, I would let x equal 2 tangent. Is that cool? Well, what is it? It's not that, it's this. So I'm going to let x minus 2 equal 2 tangent theta. That's all. Whatever the shit this is, I'm going to let it equal 2 tangent theta. So what's x minus 2 squared? Which is what I have here, right? What's x minus 2 squared? 4 tangent squared. So it's going to do exactly what I want it to do, isn't it? What? Take the derivative of this side. What do you get? 1 dx equals
2 secant squared theta.
Okay. Let me stop for a minute. Okay, so, I mean, whatever variable is here, would it matter if it was a y and a y and a y? No, whatever variables are, well, what's there? X minus 2. Okay, let that equal the trig stuff, the trig you need. Right? That sucks a little bit because what's x going to be now? What's x equal to? 2 tangent theta plus 2. Okay, sucks a little bit. Let's see what happens. I don't know. All right, so on the top, I get what you just said, 2 tangent theta plus 2. On the bottom, I get 4 tangent squared plus 4, right? And dx is 2 secant squared theta d theta. So I'm not going to promise you that every problem is going to come out to be something really nice, but the middle of the work is going to seem like, how the shit do I, you just got to have a little faith. Things are going to cancel, you're going to see some identities, so very often a lot's going to cancel. What do I do on the bottom here? By the way, do you guys see, I can factor a 2 out of the top here, right?
Mm-hmm.
This 2 combines with that 2 makes 4, so it cancels with this 4. Let me just rewrite that. All that shit canceled. There's 4 on top and there's 4 on the bottom, right?
Mm-hmm.
Tangent squared plus 1 is secant squared. And look at that. Look at that. Now, I will say that if I ask you one of these tangents or cotangent integrals, I'll give it to you. But does anyone remember the integral of tangent? I'll tell you, it's a natural log of something.
See, natural log of tangent, secant.
What's on bottom of tangent? Cosine, sine over cosine. So natural log of cosine. And what's the derivative of cosine? Sine. So it works. And then what's the integral of 1? Theta. Well, see? Yes, that's theta. I was about to ask. Hey, it's fantastic. Yes?
Can you go over the integral of tangent one more time?
Yeah, all right. So, what's tangent? Isn't it sine over cosine? Isn't that just the u sub? Right? It'd be 1 over u, natural log of u. U is cosine.
Okay.
Sometimes you'll see negative natural log of secants, because if you brought the negative back up, it'd be secant to the negative 1, which is cosine. So I prefer positive natural log of cosine. Okay. So yeah, I would feel completely comfortable giving you this because you could just write it in terms of sine and cosine, and it's an easy use of, right? You don't have to memorize natural log and cosine. You can if you want to. But like you just said, we have to figure out what these are in terms of x. This one's easy. Did I ever say? No, there it is. Okay. If I solve for theta, do you see I divide by 2, take an inverse tangent? So theta is inverse tangent of x minus 2 over 2. Right, that just comes right off of this guy. Divide by 2, take the inverse tangent. That's what theta is. To get cosine, I have to draw the triangle. What's the triangle going to be? Where does x minus 2 go if it's tangent?
Cross,
Opposite, I like it, on the y side.
and then next to it.
Good. And so this will be square root of, let's just write it like this. Well, it'll be x squared minus 4x plus 4, and you see how, ooh, look at that shit. Ooh, look at that shit. Square root this time, but oh. Okay, so then I know what cosine is. So natural log of cosine would be 2 over this. Oh, minus. Okay. Let's see. Okay, cool. Holy shit. So what you need to do if you feel overwhelmed about this kind of problem, you got to identify where you're losing connection. So if the connection is being lost at this level, why aren't you speaking up? So identifying what the sub is gets everything rolling. You take a derivative, you plug stuff in, you simplify as much as you can, and then the actual calculus starts, right? Then you get to your real integral, and you got to think, okay, how do I integrate these things? Okay, maybe. So again, this is just like everything else. You just got to get in there and try these out, right? Okay. Has anyone tried any of these out yet? You're all like, dude, I'm in 7-1, okay. All right. Okay. I was going to do a little sneak peek of partial fractions, but I think we deserve an early night. Is anyone upset about that? I pay my tuition, you better give me all the time. I've had somebody say that to me. Yes. Well, yeah, I can just keep you here. So let me know if you have questions.